We're going to look at Lewis structures of molecules that have a central atom that expands its octet. The first molecule we're going to look at is PCl5. There are one phosphorus with 5 valence electrons, that's 5, and 5 chlorine with 7 valence electrons, that's 35. Total valence electrons is 40. We're going to sketch a tentative structure for the molecule. So we're going to bond all our fluorines to the central phosphorus. We can see that already the phosphorus has more than 8 electrons. There are 5 bonds, that will be 10 electrons that already drew. Phosphorus can do that because it's below period 2. Remember, all the elements below period 2 can expand their octet. So 10 valence electrons have been used for this tentative first structure. We have 30 left. We're now going to complete the octets of the bonded atoms. Now, unlike the central atom, the bonded atoms will not expand their octet. So we just add 6 electrons per each chlorine, which will bring them to a total of 8 each. There's 6 times 4, 5, that's 30 electrons. And we're left with 0. This structure may be complete if the formal charge of the central atom is 0. Phosphorus has 5 valence electrons. It has 5 bonds, that's 10 electrons divided by 2. And then we're going to subtract also the number of lone pairs, if there is any on the central atom, that will be 0. So this will give us a formal charge of 0. If the formal charge on the central atom is 0, then that atom will not expand its octet further. Now, do atoms that can expand their octet always do so? Not necessarily. Let's look at PCl3. Now, in this case, we have 1 phosphorus, 5 valence electrons, and we have 3 chlorine. So that's 5 and 21. There are 26 electrons. Tentative structure. We have placed 2, 4, 6 electrons, left over 20. We complete the octet of the bonded chlorines. That's 18. We're left with 2 atoms that are electrons that are left over go on the central atom. Formal charge of the central atoms is going to be 5 minus. There are 3 bonds, so that's 6 electrons divided by 2, and there is 1 lone pair, so 2 more electrons. This is 3 plus 2, 5, so 5 minus 5 is 0. So in this case, the formal charge is 0. The phosphorus has 2, 4, 6, 8 electrons, so as a complete octet will not expand it if its formal charge is 0. Let's look at another case. Let's look at the structure of SO3. Number of valence electrons is going to be 6 for the sulfur, and then there are 3 oxygens, also has 6 electrons each, so 6 and 18 is 24. Tentative structure. We have 2, 4, 6 electrons that we placed. And now we're going to complete the octets of the bonded atoms. And that's 18 electrons. We're left with 0, so we have no more electrons that we can place. Now, sulfur has an incomplete octet, 2, 4, 6. Now, that cannot happen, so I'm going to move a lone pair from one of the bonded atoms to the central atom. So these will be cancelled out, and I have a full octet. Now, the formal charge on the sulfur in this case is 6 minus And I can count. That's an easy way to do it. Instead of counting the number of electrons in the bonds divided by 2, I can simply count the number of bonds. That's the same number. So I can say minus 1, 2, 3, 4, and plus 0 because there are no lone pairs, and this gives me a 2. So the formal charge of the sulfur is positive 2. Now in this case, sulfur will expand its octet to bring this formal charge to 0. So what will happen is that one more lone pair can be moved from this oxygen, form a second double bond. This will bring the formal charge on the sulfur to 6 minus 1, 2, 3, 4, 5. So we can lower it by 1 to bring it to 0 by moving another lone pair. So that will give me 6 minus 6 plus 0, 0 formal charge on the sulfur. That is the structure with the 3 double bonds of SO3 with a formal charge on the sulfur of 0. Now, do not draw double bonds all around in a symmetrical manner because that may not necessarily always happen. Let's look at the sulfide, SO3, 2 minus. Now, this is a polyatomic ion. The structure works in the same identical manner. So the first thing, I'm going to count the valence electrons. So it's going to be 1 times 6, 6, 3 times 6, 18. Now what I need to do different if I have a polyatomic ion, if I have negative charges, I need to add the number of negative charges that I have to my count of electrons. So I'm going to add 2. If it's a positive polyatomic ion, then I'm going to subtract the number of positive charges. So this gives me 26 total. Now, if I have my base structure, now I'm going to place, first of all, my 2, 4, 6, so subtract those, now left with 20. Then I'm going to place 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, so minus 18, leaves me with 2, and then I have 2 valence electrons there. If I go and calculate the formal charge for the central sulfur, because I have a complete octet 2, 4, 6, 8, but the formal charge is going to be 6 minus 1, 2, 3 bonds plus 2 in the lone pair. That gives me a plus 1, which means that the sulfur will expand its octet to bring the formal charge to 0 and will form 1 double bond. Now, at this point, with 1 double bond formed, there is a formal charge of 0 on the sulfur, so there will be only 1 double bond, not 3 like in the structure we've seen before. Let's look at the last example, that is IF4 minus. So in this case, I have 1 times 7 for the iodine, that's 7. And then I have 4 times 7 is 28. And then I have number of negative charges is 1. So that gives me 36 electrons. Now I can place the iodine in the center, bond the 4 fluorine, and that removes 2, 4, 6, 8 electrons that I already placed. Leaves me with 28. Now I'm going to place 2, 4, 6 on each fluorine to complete their octets. That's 24 that I placed. I'm left with 4. These go on the central atom. So in this case, the iodine in the center expands its octet to host the 2 extra lone pairs that I have. The formal charge on the iodine in this case Let's see how much it is. So iodine has 7 valence electrons minus 1, 2, 3, 4 plus 1, 2, 3, 4. So that would account to negative 1. Now, will it form double bonds? Absolutely not, because if you form a double bond, you're going to actually lower the formal charge. Remember that this is a polyatomic ion, so it's got the negative 1 charge. So there must be one atom that has a negative 1 charge. In this case, is the iodine. So if the formal charge on the central atom is less than 0, then the structure will remain the same. The central atom will not expand its octet further. If the formal charge on the central atom is larger than 0, then that atom will expand its octet to bring it to 0. If your element is, however, in the second period, like a carbon or nitrogen, then it will not expand its octet ever.